Hi folks, it's Mike, and this short video demonstration will show how to modify the ADSR profile of the Q109 envelope generator using the Q108 amplifier and the Q130 Clipper rectifier. Okay, so let's look at the patch so you can follow along on your own gear. The patch uses the Q106 oscillator here, and this is just being used as a gate source for the Q109. So I'm using the pulse output here in conjunction with the pulse width knob up here. And the pulse width knob will effectively set the sustain time for the envelope generator. So you want to set the range of the Q106 to the low range, and I have the frequency adjusted to about 3.5. Next we have the Q109 envelope generator here. Its gate input's coming from the Q106. Its output is going off to a Q124 multiple down below, which I'll show you in a moment. And on the knobs, you want to set the attack phase to about 0.4, and this is very sensitive in this setup. The decay to 0, the sustain to 7, and the release to 0. The reason this attack is sensitive is really just because of the oscilloscope and trying to capture this waveform. It's a very slow sweep time, so I'm using very short attack, decay, and release times in order to make it all fit on the screen. It's not really a limitation of the patch, it's more of a limitation of my ability to show you the picture on the scope. The Q124 here, which got its input from the Q109, has two connections, two outputs going to the Q108 amplifier here. And they go to the control input number 1 here and also to the signal input number 1 there. And what you want to do is you want to set the Q108 gain to 10, the control number 1 level to 0, and this mode switch to exponential. The output of the Q108 here comes back up to the input of the Q130 Clipper rectifier, which I'll show by moving the camera. Okay, the Q130 Clipper rectifier is here. Its input is coming from the output of the Q108 right into here, and its output is going off to the scope so that we can see the waveform. Initially, we want to set the clip level up here at 10. This amount knob doesn't do anything. I have it at 0, and the clip polarity is set to positive. Over here on the oscilloscope, we have two different waveforms shown. The bottom waveform is actually the output of the Q106 going from plus 5 volts to minus 5 volts. And the pulse width is adjusted so that the leading edge is right about here, goes for a while, and then it falls down. So by adjusting this falling edge, we're adjusting the release time of the Q109. The Q109 waveform is here, and the settings that we just given result in this attack, which I call a convex shape here. The decay is set to 0, but there's actually a small finite amount of decay time, which if we zoomed way in, we would see it's around 4 milliseconds. The sustain level is here. It's below the 5 volt maximum. This is 2 volts for division, so 0 is here, 2 volts there. Right now it's at about 3.5 volts. And here's the release segment. And again, you can see it's finite, even though it's set to 0. It has a release time of about 4 milliseconds again, which is, quite fast. And from a listening point of view, you wouldn't really notice that very much. Okay, next thing I'm going to do is I'm going to adjust the Q108 amplifier in order to modify this waveform of the envelope generator. And what I'm going to be doing is really exploiting the nonlinear transfer function characteristics of the control input of the Q108 to shape the envelope generator waveform. I'm going to do a separate video actually on the Q108 that shows a little bit how this nonlinear transfer function works and how you can exploit that. Just take my word for it that it is nonlinear, and because of that we're able to do some fun things here. So with that mode set to exponential, I will get the most dramatic effect. You can also set it to linear mode and you will get an effect, but it's not as dramatic as the exponential, and you won't be able to achieve some of the things that I'm going to demonstrate here. First thing you should notice that in the exponential mode there is a slight loss of gain. This peak right here on the waveform actually isn't quite 5 volts. It would be just slightly higher. It's probably around 4.6 volts, but if I switch this to linear, then it will actually be at 5 volts. So there is a tiny loss of gain. when you're in exponential mode. Now what I'm going to do next is I'm going to slowly increase the control number 1 level input of the Q108 amplifier, and we're going to see what effect that actually has on the waveform right here, the top waveform, the envelope generator waveform. Okay, starting with the control set at 0, I'm now slowly increasing the control input level. The first thing that you'll notice is that the peak of the envelope generator waveform is now actually up close to 6 volts. So it's actually showing gain. Since the input's 5 volts, we now have an output that's greater than the input, so we're actually getting gain out of the amplifier. As I continue to increase that, I'm going to go up and hit the top of the screen. It's going to be up at about 7 volts. And a couple of things I'd like you to notice before I change the scale here. Number one is that obviously we have gain because the peak here is now up at 7 volts where it used to be down at just below 5. The other thing, and it's a little subtle, but this shape here, this convex shape is actually straightening out. It's becoming more linear. So I'm going to adjust the volts per division of this scale to 5 volts per division so we can see this a little better. So again, this is now 5 volts here. We're probably close to 7 or 8 volts right now. And this attack segment is beginning to look a little bit more linear. Now I'll continue to increase the control input level on the Q108 amplifier some more. And as I do that, we'll continue to see more and more gain. And I'll stop right about there. Right now we're probably at close to 12 volts. What I want to point out is that this segment is much more linear than it was before. Actually, it's a little bit concave here and then pretty linear and maybe slightly convex, and the amplitude is up now close to 12 volts. And I've only got the knob turned to about 4.5, so I'll continue turning that up, and then you'll see the next interesting thing, which I will start to clip up here at about 13 volts. Now, remember we are running through a clipper, and I have the clip level set to 10. So that may be what's causing that clipping up there. But eventually you will hit the rails. And when you do, you won't be able to get the signal to get more positive. And you'll hit that somewhere around between 13 and 14 volts. So at this point, I only have the control level turned up to 5 on the Q108 amplifier, while the gain knob is set to 10. So continuing to turn that control level up, which I'll do, we'll notice now that the attack phase is getting more and more concave now. It's now bending in the opposite direction. There's a slight linear section here and it's clipping at the top. I'll turn it all the way up to 10 just for effect, and you'll notice that we get a pretty darn strange looking waveform. Very concave here for a segment, then linear, then clipping flat, and then the decay segment starts, the sustain level, and then the release level. So I've got several different segments in here right now just as a result of turning this up. It's not really the effect I'm looking after. So what I want to do now is I'm going to decrease the gain knob while also turning the control input knob to try to achieve something that's 5 volts in amplitude like a normal envelope generator output, but also a fairly linear attack phase. So I'll start by turning down the control level again, and you'll notice the amplitude starts coming down. Get it more linear. Now I'll turn the gain knob down. So I want to get this back to 5 volts, which is about there. Now I'll change my scale so we can see better. Now we're 2 volts per division. So that's about 5 volts. If I decrease the control input, the gain comes down, so I turn the gain knob back up. What I'm just trying to achieve is a fairly straight line for the attack segment. And probably going a little too far there. I'll back it up. So this is just the tweaking phase right now. And I'll say I'm fairly happy right about there. So what I've achieved now is, this is the attack phase, starting at the beginning. It's almost a straight line, goes right up to 5 volts, a little bit of curvature at the top. The decay starts here, sustain, and then release. Now one thing you may or may not have noticed when I was turning these knobs is that this sustain level actually has been changing as I'm turning the knobs. And it kind of accelerates. The more you have the control input set to higher and higher values, the faster that sustain level will drop. So it becomes very sensitive. But this is not a problem because all we need to really do is make up for that by turning the sustain level back on the envelope generator. The other thing I'll point out, let me turn this control level back up again quite a lot until it clips again, and turn the gain back down. I'll point out something else which you might find useful. Right now we have an attack phase that's now concave. Remember, a normal ADSR envelope actually bends the opposite direction. Now we have a concave ADSR. But if you look closely, the decay segment and the release, which if you remember were both set to 0, are actually now faster than they were before. And this is not a surprise also. Given the nonlinear shaping of this amplifier control input, it has the effect of bending these waveforms and making them steeper on the falling side and shallower on the rising side. And if we zoom way in that waveform, we'll see now that the decay time is now less than 1 millisecond, and the same thing is for the release time, less than 1 millisecond. It's still visible, but it's about 4 times faster than it was before. So if for some reason you're looking for a way to make even faster decays and releases, here's a way you can do it, just by using this patch and turning that control level all the way up. All right, the last thing I wanted to show you, which was kind of the source of this video that I posted originally, was this additional segment that we can get. As we turn that control level up and the gain level up, we've seen, I'll change the scale so we can see it again, at some point we're going to hit some clipping here. Now if I go over to my Q130 Clipper and I change the clipper level from its setting of 10 and turn it down right now, I'll turn it down to 5. Let me change my scale so we can see this a little more closely. Now I have an attack phase that's concave, goes up to 5 volts. There doesn't seem to be any decay. I'll turn the sustain level down on the envelope generator to kind of reinstate the decay phase here. And there it is. So now I have an attack phase that's concave, kind of a hold phase, a decay phase, a sustain level, and a release level. So I now have a ADSR envelope that has an additional segment, which I'll just call this a hold segment. It's not equivalent to hold in that if you let go of the key, this whole thing's going to change, but it's holding in the sense that while that key's down, it's going to rise up to this 5 volt level and stay there for a while and then decay. Now to adjust this time is actually a very complicated set of things, because if you remember, we're clipping a waveform. So to make that time shorter, we have to reduce the control input level on the Q108 amplifier, which I'll do now. So it's not clipping as much, and as I do that, you can see that segment is narrowing. And also this slope is getting more linear. If I want to move that hold segment to the left, I have to decrease the attack time of the envelope generator, which is very hard to do because it's set so fine. There we go. Now the decay time is also moving along with that, so these two depend on each other. I can increase the pulse width on the Q106, which will move this release time back, as you can see here. And by adjusting these knobs all together, I can essentially move this around a little bit. And I'll point out that the decay still works. I'll turn it up a little bit. You can see I still have control of decay. Turn it back to 0. I still have control of release. I'll turn that up and you can see release here. So I have not lost control of these parameters. It's just that now getting this waveform requires a lot of knob tweaking, which is a tremendous amount of fun. So I encourage you guys to experiment with this setup and see if you can find a good use for it like I did. And thanks for watching the video, and please feel free to leave me a comment.